morning and welcome to Trieste. Hope you will enjoy this summer course and you're staying in this town. And I will introduce Professor Iacovello, who is president of the Italian Group of Fracture. He will speak a little bit about our activities. And then Professor start his course.
Thank you, Francesca. Good morning. My name is Francesco Iacovello, and just a few words about the Group Italiano Frattura. So you have the possibility to meet us. And this is a cultural association that spreads and tries to spread and promote works and research about fracture phenomena and structural integrity. And we have connection with some foreign associations like European Society of Structural Integrity and the International Congress of Fracture. And we organize meetings, workshops and schools, like this one in Trieste. This is the second time that we are in Trieste. In fact, our activity could be structured in 3 different types of activity. We organize workshops, meetings and schools. We were born in 1981, 30 years ago more or less, and we organized up to now 20 national meetings. We organized more than 20 workshops on different subjects. 2 schools, this is the second we organized here in Trieste. We were very happy for the last one 3 years ago, and so we organized also this one. And also we cooperated in the organization of ICF 11 in Turin in 2005, 5 years ago. And another activity that we started 3 years ago is the publishing of a journal. This is a young journal, completely online, completely open access. It is completely free available online, and it is published every 3 months. And yes, with the ISBN, it is registered in the Italian court, and we are proceeding for the impact factor also. We hope in some months, some 1 year, to obtain also the impact factor for this journal. And I think that the council is quite interesting because the reference process is completed in less than 3 months. So if you want to publish something very quickly, we are able to proceed with the reference process in less than 3 months. And it is available, as you can see here, both as a PDF format and as browsable. You can browse online. It is quite interesting, also funny. And also, in the last year, we organized, I think, an interesting website. You find the address here. And in this website, you can find up to now more than 2,500 papers. These papers are completely available online. They are not only IGF papers, because in the last month, we published inside also the proceedings of some international conferences. I mean about the CRECPAT conference, the Fatigue CRECPAT conference that was organized in 2003, 2006, 2009 in Padova and in Vicenza by Andrea Carpinteri. We put inside all the proceedings of ICF 11 in Turin. Now we also publish online the last 10 years of La Pedagogia Italiana and all the 30 years, we are finished now, just now, of metallurgical science and technology. So we are trying to build up an archive where we can find the more we can inside. In the future, we are organizing also to publish inside all the proceedings of the ICF. So it is our goal, final goal, to publish more or less 6,000, 7,000 papers inside, all available for all of you. It is not exactly because some of this meeting will be available only for IGF members, but just now you became IGF members, so you will have in the next weeks you will receive a mail with the credential to enter inside the reserve section and view all the papers inside. So I think I will be able to send you the credential for the access for the end of July. We have a section with IGF journal. Up to now we have published 13 issues. You will find inside the pen, the USB pen, both the material of the Professor Schwalbe. We will find also the last issue of the journal, and you will find also the proceeding of the meeting of ISASMEC that will start after the school. And I hope that you will enjoy this pen. It's quite funny. Inside the journal, inside the website, you find also a section with the proceeding produced by IGF, a section with all the workshop, the proceeding of the workshop. You find also interesting section with the PhD thesis produced obviously concerning the fractional mechanics phenomena, the structural integrity. So if somebody wants to give us the permission to publish a thesis, it will be our pleasure to put it inside our website, available for everybody. Obviously, everything is free of charge, so we do not money about it. Don't ask us money for this. Finally, we have IGF Web TV. Well, what is IGF Web TV? It is the video recording of all the activity we have done in the last 3 years, since the national meeting in Milan that we had 3 years ago. We started with the video recording of everything. So you find also the last summer school we have done in also Trieste. We find 2 national meetings, almost all the presentation you can find inside. I think it's quite interesting. It is more or less 150 video recordings, different video recordings. It is obvious that to stay here and listen directly to Professor Schwalbe is quite different from to listen only on web and to view on web the presentation, but it is better than nothing. So if somebody can't be here, can view it or can listen to the presentation, obviously free of charge, no problem. Obviously there is also more inside the website, and we need also your help. So if you find that some section is inside our website, you could help in proposing some new section inside. We have also a Facebook page. The goal of this page is not only merely to be on Facebook because it's stupid, but to try to interact with people. So you can find inside some strange videos about, obviously, not your summer activities, but about fractional mechanics, the structural integrities. And we hope that you will enjoy our Facebook page, or you can become our friend. I don't know what exactly it means, and you can interact with us, because we need the interaction with all the IGF members, especially with the youngest among them, because I think that your sensitivity, you're able to give us more than older colleagues. So I hope that you enjoy this presentation, and a few words about our colleague here. I wish to thank Professor Schwalbe, because she was really enthusiastic to participate to our school, to our summer school. I tried to summarize his curriculum vitae. I can't, simply I can't, because it's too rich. So I tried to read something, but there is a lot of activities. He had a lot of awards. His research activity touched a lot of subjects inside during all of his activities. So if you want to give some flash about it, it will be a pleasure. But I tried to summarize. I can't. I couldn't. So I wish to thank Professor Schwalbe for his enthusiasm, for his participation to our summer school, and thank you very much.
Okay, thank you, Francesco, for inviting me.
Do you need a connection now?
No, a few minutes. I'm talking about a few minutes freely. Buongiorno, morning. I'm asking everybody to close his or her computer and listen to me and look at the screen or at the blackboard, and because using the computer is always distracting your attention. So I would appreciate it if you would close your computers. Maybe another few words about myself. I retired from my previous activity, but I'm still active in two totally different subjects of science. Number one, I'm still in fracture mechanics. I edit a journal and I teach at 2 universities and I publish a little bit. But about 6 years ago I started with something totally new. I'm now in psychology and I took private lessons and I'm studying in books and I do practice with, I should say clients that come to me and want some advice when they have difficulties in their lives. And this is very interesting, and so you learn a lot about yourself and what's going on between people, and it is absolutely fascinating. And if I had to study again in your age, I wouldn't go with fracture. I would probably do evolution biology or something like that. These are so absolutely fascinating and interesting subjects, but things are changing over the time. The topic of this course is lightweight structures. I'm not an expert in lightweight structures, that's why I was invited to do the course. And don't panic, my area is fracture mechanics, structural integrity, and I will present you some methods and ideas about how we can handle structural integrity, in particular those structures containing cracks. And I'm starting with a brief introduction. I'm showing you some PowerPoints, and then Professor Jacobiano will be talking about materials, lightweight materials. We will not be talking about design principles. This is a totally different issue. And excuse me, I have problems with my throat. And this is a totally different issue, and like I said, I will strictly confine myself on fracture and fatigue. I thought I should give you kind of a hybrid presentation. Hybrid is a modern buzzword. It used to be nano for the last 20 years, now it's hybrid. Nobody knows what hybrid means, but hybrid is fashionable. What I have in mind is a combination of things that I write on the blackboard, and because usually I do my course at home exclusively on blackboard, because I hate midnight courses, you know, when the lights are dimmed, the PowerPoints go on, the students fall asleep. This is not the way to go. So I do everything on the blackboard. It is slow, so everybody can make his or her own notes on paper. And you may know that it has been proven that if you just don't sit back and listen what the guy here tells you, when you do something on your own, you're by yourself, you write paper or you do a drawing, your brain stores this much better. Okay, so this much for neurology. And I hope that technology is okay. I leave the connection. For me, it's always a little bit like Christmas. I never know what's coming out here. Here we go. Can you see that? The colors are a bit odd. Here you see one of the many differences between men and women. And one of these differences is that men usually like more playing, you know, playing with everything, including playing war. So my favorite thing is railways, the little ones and the big ones. And oops. Get back, excuse me. You may know that, you read newspapers and you watch TV. that we have a number of societal pressures or societal goals, and one of these is, they call it saving the planet, which is nonsense. We can't save the planet, and we just want to save the environment we are used to. So I want to bring it down to earth. And one of these goals is save energy, raw materials. And one of the measures for saving energy and raw materials is making our structures lighter, because in that case you need less raw materials, you need less energy to move, for example, a piston in a combustion engine, or you move your automobile or your aeroplane, and so on and so forth. And so this is the topic we are now going to talk about. And when you talk about lightweight structures, we have conditions that are different from what we have been used to when we build a stationary plant, such as pressure vessels and steel mills and whatever. And we see a high exploitation. This thing is too short here, so I'm taking the high-tech. We have to exploit the load carrying capacity and life of our structures as far as possible in order to not waste weight and material. And so this ends up with thin wall structures, and in the case of failure, which we of course want to avoid, in the case of failure we have sometimes extended or large amounts of crack extension prior to failure. We have partly new materials. This is the subject of Professor Jacobiello's presentation. And when we go to thin wall structures, which means we have very thin, relatively thin sections, and to give you an example, when you enter an Airbus or a Boeing plane, the outer skin is just 1.6 millimeters thick. 1.6 millimeters of aluminum between you and eternity. It's sometimes a bit strange, you know. And thin materials tend to buckle when you load them, and that's why we need stiffeners. As you can see here, we have to work in stereo here. And we also have welded joints, which I will briefly touch upon. And yeah, the saddest thing is that in most cases we don't know the applied loads accurately enough. And you may know that frequently when it comes to critical parts in aeroplanes or in automobiles, that test drives are being done and people put strain gauges on the critical locations to measure what's happening during a representative, whatever that means, representative test drive or test flight or whatever it is. But whenever you encounter a very hard, gusty flight through a thunderstorm, you are not quite sure whether the engineers have really recorded the highest load peaks. Now, also we have environmental effects, which I'm not going to talk about. This is a separate, very wide area. And now the question arises, how can we learn about the integrity of such a lightweight structure? And a trivial thing would be to do a full-scale test. And like the one you see here, this was done some 70 years ago, and I like it. I show it in almost every presentation of mine. And so here, this is what they call the DKW, which was a forerunner of Audi. You see the four rings here. So this is an old-timer Audi, and this was a test mode. And the men here don't look very, very happy. I don't know why, but well, this is an example of a full-scale test, which doesn't make much sense because you would have to test every car, every kind of material you use, and so it's just for fun here. Now, the content of what I'm going to tell you of the whole course is, oops, I'm sorry. And After my introduction, I will talk about fracture mechanics concepts, a little bit about fatigue, mismatched valve joints, very interesting subject by the way, and then assessment models. And if time allows, I don't know how far we get, usually I start talking and end somewhere, and there's always a danger when somebody invites me to give a talk. I never know when I'm going to stop. And there's a very interesting numerical damage model, the cohesive model, which we use, which we haven't invented it, but we have put it into kind of procedural form, so we have put it down into the form of recipes. So this is the layout, and sorry, there's still a few more slides. When you talk about lightweight structures, or we want to meet the societal goals that I was mentioning, one measure is we have to increase the efficiency of energy conversion. You know, this is a hot topic now in automobiles and also in aeroplanes, and in the generation of electricity, all the turbines and whatever are becoming more and more efficient. And coal plants, if you really think about it thoroughly, we have a big coal plant for maybe 500 megawatts of energy. More than 50% are just going to the air. To heat the atmosphere, that's nothing. It's totally wasted. So that's, at this moment you start thinking, of course. Now, our goal is, or our subject is weight reduction and reliability. And here we go. We could go with higher strength material, which is trivial, but there's a problem which I will touch upon later. Or we go to lighter materials such as polymers, titanium aluminides, magnesium alloys, aluminum alloys. By the way, this is a very interesting class of materials. I guess most of you have never had any contact with that. And these are for high temperature applications up to 800 degrees Celsius, for example, for turbine parts, for valves in automobiles and for coatings, but still not ready for mass production. We have been developing these materials for the last 30 years. So the cycle, the time it takes from having an idea for a totally new class of materials and putting this into a mass production is sometimes disappointingly long, so you can spend all your lifetime on a new material. When you invent a new material, you know for sure that you can work on it until you retire. And we may use new production techniques in joining, in forming. Very interesting is forming after welding, which has problems because a weld seam has different properties as compared to the blank you are about to form, and so there are difficulties with that. But it's very, very promising method. And we have a number of welding, not tip joining, for example, but welding methods. A very interesting one is the so-called friction stir welding. Unfortunately, I can't go into the details because it is a subject of its own, but it is a mechanical welding process, and you put the two parts you want to weld together. They are clamped on a base plate, and there is a pin that rotates. You can use a simple milling machine, a console milling machine. You don't need a big apparatus, and you have a special pin made of a special hard material. It rotates, and it migrates along the gap between the two parts you want to weld, and it stirs, and by stirring the material becomes soft. It doesn't melt, it's still in solid condition. So like a dough, when you want to make a cake, you know, you stir the dough, and in the end you have an almost perfect weld. It's absolutely amazing, and we were the first to combine this with robots so that we can make also curved 3D welds, and the properties are just wonderful. Okay, Yeah, high exploitation of structural mass. We have to be able to quantify structural behavior using classical fracture mechanics and the more high-tech damage mechanics. This is the main thing I will be talking about. And yeah, if we are able to perform what I just touched upon, we will have more precise estimates of life cycle costs. This is a very important thing. I mean, whenever you go to industry and your company has to sell a turbine for a power plant or for an aeroplane, their engine, or you sell a bunch of locomotives to Thailand or Russia or wherever, nowadays you don't just sell the hardware, you sell for either the complete life cycle, 30 years, or for 10 years including maintenance, and you have to guarantee a maximum amount of cost, life cycle cost. This is very risky, and the people sometimes walk on thin ice. And this needs careful estimate of the real life cycle costs, including dismantling at the end of the life cycle. Yeah, so, and in the end it's supposed to be more economical, and we have just repeating, increased energy efficiency, and if we quantify everything, we can probably have shorter downtimes, because downtimes for a plane, you know, you have to send the plane into the workshop, or you have to shut down your nuclear reactor, or whatever it is, your locomotive. You may have heard about the disasters we had in Germany with the high-speed trains. It cost the Deutsche Bahn an awful lot of money for that very reason that was a problem, yeah. And downtimes, like I said, are very expensive, and in the end, hopefully, we have lower repair costs. And now, Francesco, it's your turn. Thank you.